Welcome students. In the last video session, we have seen what is mechatronic system, why microcontrollers are used, and what is the role of microcontroller in mechatronic systems. And in this video session of second one, we will see basically how the components are connected to microcontroller. So you could see here the switch sensors which is connected to the microcontroller. You can see here the switch sensor and the switches are directly connected to the port pin through a resistive network. So the switch sensors, it has two states, either on state or off state. And here also the switches which you can switch on or switch off. And it is a very simple connection. Directly you can connect it to the port pin through a resistor. And coming to the sensors with the pulse output, this can be connected to a microcontroller. Again, it is connected to the port pin of microcontroller through a resistive network. So these sensors will produce a pulse modulated signal. So you can see from the, you can get these signals from the accelerometer or encoder, where this is purely used for the measurement of rotation angle and velocity. And you could see in the insert diagram, you have the pulses which controls the rotation, either turning right or turning left. And pulse width modulated signal is very frequently used for controlling the speed of the DC motor. And almost every microcontroller has built-in counter, timer for reading and generating these pulse signals. And similarly, the other common component used in the mechatronic system is RC servos. RC servo is a positional servo mechanism which consists of DC motor, positional sensor and control electronic. There are two types of RC servos. One is rotational, the other one is linear servo. And the controlling of these servos is purely with the conventional RC signal. So it generates a pulse width modulation signal, and this width of the pulse constitutes a value of the desired position of either the angular horn in case of rotational servo or linear shaft in the case of linear servos. So this normally produces a pulse width which lies in the range of 1 millisecond to 2 millisecond. And the delay between these pulses will range from 10 milliseconds to 20 milliseconds. You could see in this diagram, so the pulse width of 1 millisecond makes this position of this rotational servo to minus 90 degree, and 1.5 millisecond makes it to a 0 degree, and 2 millisecond makes it to a position of plus 90 degree. And similarly in the linear servo, you could see here the 1 millisecond, the linear servo shaft is forwarding, and similarly 1.5 millisecond, the linear servo shaft is moving out to end position for a pulse width of 1 millisecond and a pulse width of 2 millisecond, which causes the forward shifting of the linear servo shaft, which could be seen clearly in this diagram. And here microcontroller based electronic module for controlling mechatronic systems. So this I'm going to explain a very simple electronic module where you could develop for a mechatronic system. So it is a single chip electronic module commonly used for industrial control, and this basically consists of a 16-bit RISC microcontroller. RISC is nothing but reduced instruction set computing. It is used for mechatronic application, especially an electro-hydraulic position control system. It could able to handle a large range of mechatronic systems, and simple implementation of digital PID algorithm makes the module suitable for control of hydraulic applications like railway hydraulic damper test bench or hydraulic presses for recycling materials. The heart of the module is a 16-bit advanced RISC system on-chip microcontroller with large memory resources. So say example, it has 2 kilobytes of RAM, 60 kilobytes of flash program memory, and it has integrated peripherals, direct memory access controller, 12-bit A to D converter, D to A converters. It has timers, counters with capture, compare inputs and pulse width modulated outputs. Even it supports both synchronous and asynchronous serial communication interfaces. Of course, this microcontroller has a watchdog timer. And here this direct memory access controller, it is used for making the transfer of data in a vast amount. So very quickly you can transfer the data. And this shows basically the structure of a microcontroller used for mechatronic applications. So as I've shown here, as I told you already, it is a 16-bit microcontroller where it could take the analog inputs, it could take the digital inputs. When I talk about the analog inputs, it takes either from a inductive or resistive sensors, and mostly the available sensors nowadays is of resistive sensors. And similarly, when it comes to the digital inputs, either it can be from the contacts or from the humidity, pressure, temperature, hall sensors, any type of sensors which could generate a digital input, a digital thing. And this is fed into a 16-bit microcontroller. If it is going to be a digital input, so the microcontroller will take it as such. If it is going to be an analog input, then this need to be converted into the digital, which is done by the inbuilt microcontroller. And when I come to the output side, you could see here it generates a pulse width modulated outputs where you could connect the actuators, where this is used in the rotational movement or positional movement. And you could see here it can be connected to the 10 amp relays, where in turn this can be connected to the contactors, motors. And similarly you have here open drain power outputs, where this could be connected to the servo valves. And here you could see a RS485. It is a serial standard. This can be connected to the PC, where it can communicate to the outside world. And to give the commands, to give the inputs or any instructions to this microcontroller, probably I can interface a keyboard with it. And similarly, I want to read the output, or I want to see certain commands which is as an output, then I can go for an LCD interface, which is interfaced with the microcontroller. Normally this consumes less power. It takes either a 3.3 volt to a 5 volt. So this is the basic structure of a microcontroller based module, which can be developed for different mechatronic applications. In the next session, we will see certain real-time applications. Thank you.